How to convert a binary number to a decimal number. In this tutorial, we will describe how to convert a binary number to a decimal number. For example, let us convert the following. Okay, we're going to try to convert a binary number to a decimal number. For this example, we have the value 11001101, and of course that's in the binary system, and we're going to say that it equals the value 205, which is in the decimal system. Before we begin the computation, let's look at the notes to the top right. Since we're dealing with binary conversion, we're dealing with two digits in the binary system. The value is either 0 or 1. If we have a 0, it represents off. If it's 1, then it represents on. So let's begin. So what we want to do is we're going to convert the binary value to decimal. So our expected value would be 205. So what we want to look at is we want to pay attention to the actual positions of the value. So we can say this 1 here is in the 0th position. This 0 here, it's in the first position. 1 is in the second. This 1 here is in the third position. This 0 is in the fourth. This 0 here is in the fifth position. The 1 is in the sixth position. And the last one is in the seventh position. So these positions, since we're dealing with binary numbers, they're powers of 2. So in this position, it represents 2 to the 0 power. The next one, the first position, represents 2 to the first power. The second position represents 2 to the second power, and we just keep going. So we have 2 to the 4, 2 to the 5th, we have 2 to the 6th, and 2 to the 7th. Alright, now we look at the notes up here. We said that we have 0 that represents off, and if we have a 1, it represents on. So we look at the values in this binary system here. We have 11001101. Well, what this represents, things are on and things are turned off. So let's look at the first position here. We want to say it has a 1, so that's turned on. So we kind of follow the path. We'll follow the path, and it says that we should consider this computation. So we will put 2 to the 0 here will be included in our computation. 0 in the first position, it has a value of 0. So it's turned off, so we will not consider this in the computation. So the next digit is 1. It's turned on, so we will consider this value in the final computation. So it's 2 to the second power. Same for the third position. So at 2 to the third. For the fourth position, it's turned off. For the fifth position, also turned off. And when we look at the sixth position, it's turned on. So we will consider this in the final computation. So it's 2 to the 6th power. And also in the seventh position, it's also turned on. We will consider that in the final computation. So all we have to do now is we want to add all these and let's take it down one more level. So we know that 2 to the 7th power is a value of 128. So this is the same as saying 128 plus, we have a value of 64, which is represented as 2 to the 6th. And then we add 2 to the 3rd power, which is a value of 8. And then we have 2 to the 4th power, which is 4. Then we have 2 to the 0th power, which is the value 1. And when you add it up, you have the value 205. And thus what this shows is that the value 11001101 in binary is equal to 205 in the decimal system. And this is what we wanted to show. Next, let us perform another binary to decimal conversion. This time we will convert numbers with a decimal point. Okay, so this time we have a binary number that includes a decimal point. So it's pretty much the same algorithm, except we have to consider digits towards the right will have a negative exponent, and digits toward the left will have positive exponents. All right, so let's begin. So this one, since that decimal point is right here, the one to the far right, the least significant one, is actually 2 to the minus 2, because it is 2 positions from the decimal point. So the one digit behind the decimal point is in the minus 1 position, because it's 1 position to the right of the decimal point. And then for the other digits on the left side of the decimal point is exactly how we performed the computation in the previous example. So we have this 0 here is going to represent 2 to the 0 power. This one is going to be 2 to the first power. This one will represent 2 to the second power. This position will represent 2 to the third power. And so the 0 is turned off. I'm not going to consider it. So that represents, this 0 represents the 4th position. So that means this 1 here is 2 to the 5th, or actually represents the 5th position. The next 0 represents the 6th position here. Since it's turned off, we're not going to consider it. And the 7th position is turned on, so we will consider it into our computation. So all we have to do is add all the values up. And let's see what we have. So let's break it down further. So we know 2 to the 7th power is 128. And we know that 2 to the 5th power represents the value 32. And 2 to the 3rd power represents the value 8. We have 2 to the 4th power represents the value 4. 2 to the first power represents the value 2. 2 to the 0th power represents the value 1. And we have 2 to the minus 1. So let's go over here and break this down so you can see what's really happening. So when we have a value 2 to the minus 1 power, it is exactly the same as saying 1 over 2 to the first power, which is the same as 1 over 2, which is 1/2. So we could say that that's 0.5. Okay, and we add the next and final least significant value. Again, this is 2 to the minus 2 power. It's the same as saying 1 over 2 squared, which is equivalent to 1/4, which is a value of 0.25. And so we add it up and we get the value 175.75. And thus this shows that 10101111.11 in the binary system is equal to the value 175.75 in the decimal system. And this is what we wanted to show. This puts us in a position for my next tutorial where we describe how to convert from binary numbers to hexadecimal numbers. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also, feel free to join us here at the Computing Sector. There will be more videos and tutorials coming soon. Thanks.